let's go over the discriminant of the quadratic formula. So I have here the quadratic formula up here, and the discriminant is this part, everything underneath the radical, the square root here, okay? So everything under the square root is the discriminant. So I'm going to label that, and we're going to call that discriminant is equal to our b squared minus 4ac. And I'll put that right here in green here. So discriminant is equal to b squared minus 4ac. So this is the discriminant. And what is really neat about the discriminant is that you can use it to determine, before you even calculate through your whole quadratic formula here, what your parabola is going to look like, particularly what the roots are going to be. So I have a few cases on the other board here. Let's have a look. So on this board, I have 4 kind of axes here with 4 different scenarios that you could run into. So you could end up with 2 imaginary, or we'll start down here. Let's do 1 real root. What does this look like? Well, it looks like a parabola that touches the x-axis once. So it comes down or up, comes down like that, touches the x-axis once, right? Now, how would you get, with the discriminant that we've listed over here, how would you get exactly one answer? Well, it turns out that the reason you have 2 answers that pop out of the quadratic formula is this plus or minus, right? So as if the discriminant over here just went away, if this wasn't here, you would get 1 answer. If I covered this all up, you'd get 1 answer. So how do you make this go away? Well, let's set the discriminant equal to 0. So I'm going to put that here. When the discriminant equals 0, you get the 1 real root there. Now let's look at 2 rational roots. So what does this one look like? Well, this one looks like, so you need to have 2 actual roots, 2 real roots here. So I'll put 1 here and 1 here. The parabola goes through both of them like that. What's important, though, because these are rational, these have to be non-radical numbers. They can't be there can't be any square roots in your final answer, basically. So this has to be some value like -4, and this one has to be 4, right? You can't have any square roots there. Well, if we come back to our discriminant, we have this square root in our quadratic formula. And if we're not careful, we're going to get a square root in the answer. What does being careful mean? Well, it means that we have to make sure that the discriminant is a perfect square, such that when you take the square root, you get a whole number and not some kind of or not a whole number, but you get a rational number, not some kind of radicalized number. So it has to be a perfect square. And it has to be positive, so that you can actually take the square root. So discriminant, perfect square here. Square, I'll put that. That is positive. All right. So the next one we can go over is 2 imaginary roots. And with the 2 imaginary roots, this is when a parabola doesn't even touch the x-axis. So that just comes down and up. There's nothing there. In this case, the discriminant, you have to get a situation where the discriminant is imaginary. Well, what does it mean to be imaginary? It means that whatever's under that radical is negative. So for a problem like this, it's very simple. You just you just find the discriminant that is, if you find the discriminant that is negative, then you know that you're going to have two imaginary roots. So we're going to say that this discriminant is less than 0. And finally, we've got our two irrational roots. This is very similar to our rational one, except we want it to not be rational. So in the rational case, we wanted to make sure that they were perfect squares. So with this parabola, we still have our two roots, but in this case, we want these to be, again, we want these to be square rooted, or numbers that are rooted. So this is maybe negative root 3, and this side is root 3. Well, to get this, your discriminant has to be not a perfect square. So, and it has to be positive. So similar to up here, it has to be not perfect square. And positive. So that's some of the discriminant stuff. Using these kind of rules, you can figure out what your polynomial, what your polynomial will look like once you've plugged in all the numbers.